Hi, we're the founders of Arachnid Systems. We're building AI-powered robotic inspection technology to find defects faster and more consistently.
Aerospace maintenance and manufacturing are still plagued by slow manual processes that lead to huge bottlenecks. Having worked at Lockheed Martin and JPL and talking to other aerospace companies in El Segundo, we have collected intel that this is still a problem yet to be solved. Arachnid solves this problem by using our own proprietary software and hardware.
While working at Apple, I saw firsthand how we solved past the supply chain bottleneck with distributed data collection. This proactive pipeline we developed is the solution for industries in aerospace where the work right now is reactive.
At Arachnid, I work on product and AI, turning inspection data into models that detect and track surface and subsurface defects.
I'm the CEO, and I work on making our roadmap align with our customer pipeline and also work with clients to make sure our workflow meets their demands.
We're starting with aerospace first, but this problem goes far beyond aircraft. We see our technology helping inspect other safety critical assets, including launch pads, ships, buildings, and infrastructure. We have collected data from all these sources, built a synthetic training pipeline, and have a working prototype.
Our long-term vision is to create a health monitoring system for physical infrastructure capable of diagnosing, reporting, and supplying the aerospace industry. We want to make flashlights and guesswork into an assessment with a part number just a click away.
We would love to be part of the SkyDeck community because we need the mentorship, customer and partnership introductions, and investor access. This network will be invaluable to Arachnid's potential to grow and scale.
Thank you for your time and consideration. We hope to meet you all very soon. Hi, my name is Ben. I'm the CEO of Arachnid Systems, and I'm going to take you through our product. What we do is we actually take different sensors that are in wavelengths that humans can't see to understand how aircraft and heavy industry deteriorates and how it needs to be maintained for the future. Most of the inspections that are done are done purely with a flashlight and someone who has industry knowledge. But in aviation, over 47,000 maintenance workers are going to be retiring in the next 5 years, and all of their expertise is going to be moving away. So in order to keep that tribal knowledge and extend the way that we actually manufacture and maintain these aircraft, we need a different system to actually collect that data and start to interface with it, and that's what we do. So here you can see a live video of our model working on a drone. This is something that we will be making autonomous and actually collect these samples. And I'm going to show you in just a little bit about how this data is processed and how it actually shows up to people that are on the ground. Right. So this is our current progression right now. We have our V1 complete actually, and I'm going to show you guys video of this working right now. But what it actually does is actually can run any proprietary model that we write to it, but also stream all the data and save it to be processed later on. So we actually can layer in 3D. This YOLO model is simple, but it lets us get the point across of training a model, having it show up on the feed itself, and actually being able to help people on the ground actually look at what the defects are without having to resort to using our system in a larger capacity. Now that we've finished with the iPad, we're going to be moving to a monolithic model that lets us have all the AI, all of the sensors, and all of the rest of the future roadmap for sensors to be applied into one interface. So this is going to let us control the aircraft, control the fleet, be able to look at reports, having a desktop interface or having to drive the aircraft themselves. And so I'll show you in a little bit how it works on here and how it works on a drone, but that's kind of the progression of the different modes that we can do to inspect. This is how it looks like when it's mounted on a drone. You'll see the same RealSense D455 marked on here, and one of the key benefits of that is that it's able to create a consistent data set for us to train on, and that lets us actually do a better job in the future. So you can see it going across this tank, and we actually are able to make some really great scans with it. So this is a scan that came off of it. It looks really good, and this is what's actually going to help us even produce even better training data that relates to the specific sensors that are on it. And this is our previous version with just the D455. So pairing it with a really high quality camera is actually able to give us a lot more insight. But you can see how much we can pick up even without having that, and we can even tune to the severity of that defect. And so what we produce is actually detailed visuals of what needs to be looked at and why. And we actually compiled that into a PDF here for systems to look at. And then we can actually organize this data to make statistical determinations on defects across an entire fleet, across the history of an aircraft. If an aircraft is leaving an airport and arriving in a different area, how do you check up on a repair that's been done there? Remember, we do this through the lens of $150,000 per hour. That's how much an airline itself is losing on the ground, and can even be more in a military setting. So for the F-35, their costs and readiness have gone below the threshold. So an F-35 is supposed to be 75% ready at any given time, and right now they're hovering at about 45%. So for us, this could be a huge capability increase without them having to increase the manufacturing costs for those parts in the aircraft themselves. And this means that we can extend this to other industries such as mining. You can see here that we have a really detailed scan, but we actually can do this in thermal as well and actually produce points that are very specific to what's going on in their theory. So this is the actual interface that we're going to be shipping. This is what it kind of looks like right now. It's basically a demo of all these different use cases compiled into one. So you can see here we have all these different critical alerts on different aircraft that are currently in inspection. We have different, modes and different ways to filter through the data that we have and actually do checkups, do assessments, actually complete a pass, and actually send. You can even highlight it to be, compared again to do that. So we can. You can get into this later, but basically this is going to be letting us browse through different defects, different areas, remotely connect to a drone to do a bespoke inspection on a certain area without having to send someone out to make that really long look. So you can actually jump right back into what the drone picks up, actually make determinations. You can even move into the records and actually manage the logistics. So you can see we may change our ranking here. You can actually go into logistics and actually look at the stuff that is coming in, prioritize it, manage the fleet, manage how it's handled. And so we really like the way that we've set this up. And this is set up to work with the current naval and Air Force repair statuses. What we're going to be bringing into this in the next couple months is actually our staging and inspection pathways, so we can actually tell an aircraft how we want it to do the inspection, how to repeat this inspection over and over, how you can train it to do that. And so we've already built that pipeline. We're just weaving it all together to make one giant look. And so our new hardware here that we're ready to ship is going to be basically this with the hardware for sensing inside, as well as remote wireless secure connection to manage the entire fleet and manage your entire aircraft system. And so we charge for hardware, we charge for the software, and we charge for the actual maintenance of our equipment to be calibrated to FAA specifications. So we hope to get that done within the next 2 months with them. They're very excited about the record-keeping aspect of it, and they're really passionate about this new side of technology, which is something you really don't see a lot with the FAA. But current status of the maintenance system is just paper records, with just experienced veterans, as opposed to a unified collection system, which they think is a really key feature to ours, and is going to let them move into the new century and be able to actually capture over 30% of lost revenue because they don't have good maintenance records. So we're really excited to join SkyDeck this year. Thank you so much for your consideration, Arachnid Systems.